Hello, welcome to 2H TV. In our last class, we look at how to express solubility products when a compound is given, right? So we said that in our following class, we are going to use that understanding to solve for either the KSP value or the molarity of the compound. So let's look at these two questions in today's class. The first question reads: the aqueous solubility of calcium sulfate is 0.015 molar at 25 degree. What is the KSP of calcium sulfate at 25 degree Celsius? Then the second question reads: the mineral fluoride is calcium fluoride, that's CaF2. Calculate the solubility of calcium fluoride water from the solubility product constant of 3.4 times 10 negative 11. So we are going to use that understanding that we had in our previous class to try to solve this. Let's quickly dive into how we are going to solve this. So question one, the compound given is calcium sulfate, right? So the first thing is it will dissociate into its ions, right? So that will be Ca ions and what? SO4 ions, right? So the charges are calcium is +2, CO4 is 2 minus. We check whether it is balanced. You could see that the equation is balanced. Now they have given us the solubility of calcium sulfate to be 0.015 molar. So our KSP expression, right, is equal to the concentration of what? Calcium 2 plus multiplying SO4 2 minus, right? Now we have been given the concentration of calcium sulfate, so it means that the KSP is equal to concentration of calcium is 0.015 multiplying the concentration of SO4 2 minus, which is also 0.015, right? So we have to find the KSP. So we multiply this by this, quickly doing that. That will be 0.015 times 0.015. That will give us 2.25 times 10 negative 4. So the KSP is 2.25 times 10 negative 4. So this is your KSP. So let us quickly look at question 2. That's the last question of the day. The compound given is calcium fluoride. When you dissociate this, it forms calcium ions plus fluoride ion, right? And we said that the number in front of the anion becomes the charge of the cation, so 2 plus number in front of the cations to become the charge of the anion, so -1. Check to see if it is balanced. Calcium is 1, fluorine is 2, so we put 2 in front. So quickly writing the KSP expression: concentration equal to the concentration of what? Calcium multiplying 2F minus exponent 2, right? So this is the KSP expression. Now we are given the KSP value, right? So the KSP value is 3.4 times 10 negative 11 is equal to concentration of calcium ion. Let's say it should be X, right? So X times 1 exponent 1 is same X, multiplying, there is 2 here. Concentration of fluorine should be X, so 2X all exponent 2. So when you express this, you get X multiplying 4, because 2 square is 4, S square is S square. So that will be 3.4 times 10 negative 11 is equal to X times X exponent 2. So when you do that, you get 3.4 times 10 negative 11 is equal to x. Will multiply this will give you 4s cubed, right? So let's try to make s the subject. Let's try to make s. So making s the subject, let's rewrite the equation at this side. That will be x 4s cubed, right, is equal to 3.4 times 10 negative 11. So making s the subject, we divide by 4, so you get s cubed now is equal to 8.5 times 10 negative 12. So to find x, to make s the subject, we find cube root of both sides. So s is equal to cube root of 8.5 times 10 negative 12. So when you use your calculator to divide that, you get your x to be 2.04 times 10 negative 4 molar. So this is your solubility of fluoride water, right? It's 2.04 times 10 negative 4 molar. So this is how you go about calculating. You see, they'll either give you the KSP for you to find the solubility, the molar concentration, or they'll give you the molar concentration to find the solubility product constant. Thank you so much. Please subscribe, share, like, and comment.